Alrighty. So let's talk about how we balance chemical equations. And balancing is so that we don't have violations of the law of conservation of mass. That just says that that matter, up here, matter, and we've learned since then that atoms can be neither, that's an N, that matter can be neither what nor what. Yeah, you've heard that before. Created nor destroyed. Okay. So we balance a chemical equation so that we can account for all of the atoms in the reactants over in the products. So we haven't lost any atoms, we haven't gained any atoms. Okay? So if we looked at H2 plus O2 making H2O, okay, and if it was just like this with nothing else to it, okay, we draw these little blanks in front of each of the reactants now when we're learning how to balance equations, because that will be the way that we balance. We're going to put numbers in front of each of those formulas to say how many of that formula we're talking about. Okay? And if there's no number, okay, if it's just blank, or if we didn't even have those blanks, if we just said H2 plus O2 plus H2O, does that mean 0 of all of those things? If there's no number, what does that actually mean? How many? Yeah, that means 1. Okay? So what we can do before we even start out anything, we can put little 1s in parentheses there. We'll do that a couple of times just as a reminder that no number out in front means that we have just one of that formula. Okay? So if this were the way that that reaction went, that we had one H2 and one O2 making one H2O, does this is this correct, or does that violate the law of conservation of mass? Or it violates it. Why? What's the problem? And you can look at the little figures there to help. Yeah, look at what we had. We had 2 H atoms. Here, let's draw a little line down on the bottom here. Okay, and let's draw a line by the arrow there to separate the reactants from the products. Okay, got reactants and products. And down here, let's count atoms. Okay. As it is just right now, how many H atoms are there? There are 2. So let's say H 2, O also 2. Over here, H2, but O. Okay? And it's important that we know what atoms are and molecules are. We talked about that way a long time ago, but if you misunderstood that, you're going to have troubles here, right? What does this 1 represent? What do we have 1 of here? That is a molecule. Okay? This is an H2 molecule. Okay? And this is an O2 molecule. This is an H2O molecule. Okay? These numbers are saying how many of that formula it is. And if it's a molecular substance, those are molecules that we're talking about. Okay? So this one H2 molecule contains 2 H atoms. And it's the atoms that tell us whether or not we've violated conservation of mass. Okay? So since we're obviously short an O atom over here, there are a couple of things that you might be tempted to do that are incorrect. Okay? First of all, we're not just going to throw in another O atom over on the other side. We can't just say plus O, okay? Because we know if you're given the equation like this, these are the reactants, H2 and O2, and H2O is the only product. Can't just go making more products, okay? Different products. So you can't do that. You also might be tempted to say, well, could it just be H2O2? Anybody know what H2O2 is? We talked about that once. Well, that's hydrogen peroxide. Okay? It's a totally different substance, and that's not what we have here. Okay? You're told that hydrogen and oxygen combine to make water. So you can't just go and change things by saying no, it doesn't make water, it makes peroxide. Who are you to say what the reaction actually forms? Okay? The only thing we can do is change these numbers out in front to say how many of that formula we're dealing with. Okay? You can't change the formulas. So over off to the side here, let's have a couple little notes. Cannot change the formulas to balance. You can only change those numbers out in front, which are called coefficients. Okay. So, if we have these two oxygen atoms, and we can't have oxygen atoms just disappear, what could I do with this coefficient to at least keep our oxygen atoms equal? What could I change that coefficient to? What do you think? Because remember, this coefficient, this says 1 water molecule, but we can change that. How many water molecules would we actually be making here, assuming that we're not destroying any O atoms? Yeah, you'd be making 2. You've got this O atom and that O atom. Okay, maybe this one can go in this water molecule. We'll have another O atom. Let's draw another water molecule. Okay, draw an O, draw the 2 little H's sort of attached down to the side, like that. That's another water molecule. So if we change that coefficient to 2, there are now 2 water molecules. Okay. Yeah, so what we have to do, anytime you change a coefficient, you have to update your atom totals. Okay? Because how many H's do we have now? You can just count them. We got 4 H's, we got 2 O's. Okay? You can just sort of look at our little picture here, or you can take this coefficient and multiply it into that formula. Because if you got 2 H2O's, now you got 2 times 3, you got 4 H's, and you got 2 O's. Okay? So that helped us out. We haven't destroyed any oxygens now. Okay? But now we have created these 2 hydrogen atoms from thin air. So what do we have to do to make sure that we haven't created hydrogens out of thin air? Well, let's change this coefficient right here to a number 2. Okay? So draw another hydrogen molecule there. Hydrogen molecules. Now have 2 of those. Okay. That's literally what a hydrogen molecule looks like. It's 2 H atoms stuck together. And by the way, how come it's 2 atoms stuck together for hydrogen and for oxygen? Those are diatomic elements. So that there is a reminder. So again, if we have just an elemental substance like hydrogen reacting with another elemental substance like oxygen, okay, anytime you have a diatomic element, its formula will exist as a pair of atoms, and that's very important in writing chemical equations because we're not talking about lone H atoms here. We're talking about pairs of H atoms, and that's the thing that we count over here. All right, so what do I need to update down here on my totals? We need to update hydrogen because now we have 4 hydrogens. And now we know the chemical equation is balanced because what can you say about the atoms now? Yeah, we got the same number of atoms on the reactant side as product side of each element. We've got 4 H's on each side. We've got 2 O's on each side. The equation is balanced. Okay? So that's the goal here. The coefficients, okay, are these numbers in front of each formula. So it's going to be very important. If we're writing an equation from scratch, it's going to be very important we have the correct chemical formulas first, And if we need to use charges or whatever we've been doing, we write the correct formulas first, and then, and only then, do we go through and look at the left side and the right side to balance it. Okay? You cannot change the formulas to balance, just for the sake of balancing. You can only change those coefficients. So let me give you a couple of hints for balancing equations. I'll tell you a couple of things to do that will make balancing a little bit easier. But really all it is getting the atoms on the left equal to the atoms on the right. Okay? Let's do C, H, and O for our little tallies here. And I think at least until you're totally used to it, I really like drawing that line down the middle because that reminds you that we're taking the whole reactant side and the whole product side to get them equal to each other. Okay? So let's total them up. 1 carbon, 4 H's, 2 O's. Okay? 1 carbon, 2 H's, and how many O's do we start with over on the product side here? 3. Okay? Don't forget, a lot of times an element will appear in multiple compounds, so you got to find it in all of the places. So there's O2 over here, and then there's another O over here. So there's 3 O's total, okay, to start with. Okay. My trick here was to say leave elemental substances for last. We've got several molecules, but one element. Which one is the element that we've got here in our reaction? Yeah. CH4 contains carbon and hydrogen, right? Carbon and oxygen. O2 is the only element. So it's the only elemental substance. So we're going to save that one for last. We're going to get everything else balanced because we can put whatever we want in that box and it's not going to screw up any other element. Okay? So, nice way to do it. So I'm not going to worry about O yet. C looks okay to start with, at least, but H, what am I going to do to get H equal on both sides? What do you think? Should I change this to H4O? Yeah, we need to have how many H2Os total over on the right here? Okay, we need to have 2 H2Os total. Okay, so remember, I'm going to write this word down here. That's a coefficient. The coefficient multiplies the formula. Okay. That coefficient is saying how many of that formula do I need over on that side. Okay. So update that too. We now have 4 H's. How many O's do I have now? Yep, because I got 2 over here. I've got 2 times 1, okay, 2 in that one, so I've got 4. Okay. So then, if I'm saving oxygen for last, now I've got carbon good, I've got H good. Now we can put something in there. What number should I put in that box then? That one's not so bad, right? Let's put a 2 in that box. 144, 144. It is now balanced. It is perfectly acceptable to leave it like that. What do these blanks mean? The same as? Those blanks mean the same as 1. So if you want, you could put a 1 in parentheses if you like. Okay. It's just as a reminder. Okay. That's like multiplying by 1. Right? Same sort of thing. The only thing to be careful of in a mastering chemistry or a D2L type quiz situation, follow the directions carefully because sometimes it will tell you never leave a blank coefficient. So it may tell you that you have to enter a 1 if it's a blank coefficient or something like that. So follow those instructions carefully when you're doing balancing on a homework system or something like that. Okay. All right. So let's start this one the same way. C, H, and O. C, H, and O. Okay. Same sort of deal. Here's O2. We're going to save that for last. So why don't you total up all the elements before any coefficients first. So total them all up, probably 4, 10, and 2. Now, in this case, you have to balance carbon, and you also have to balance hydrogen. So why don't you see if you can write coefficients in for to get carbon balanced and hydrogen balanced. But again, we're going to save O for the end because we've got an element. But stop when you get to O, and we'll talk about how to deal with that. What did somebody do to get carbon balanced? If we put a 4 in front of CO2, that gives us 4 carbons, but then we have to update O's as well. Yeah, I've got 4 times 2, I've got 8 O's over here, but I still have one more O over here. Right? So I've got 9 O's. Right? Then what about H? Five? Yeah. Why do we need 5? Yeah. So 5 in front of what? 5 in front of H2O. Because I've got 10 H's total on the left. If I want 10 H's total on the right, I'll have to do 5 times 2. H2 in there. Okay? So that's 10 H's. Now how many O's? Yeah, that gives you 13, because I've got 4 times 2. Okay? I've got 8 over here in CO2, plus 5 more. As far as I know, 8 plus 5 is 13. I always had trouble with 8 plus 5 for some reason, but yeah, 8 plus 5 is 13. So, all right. What I said up here on my little tip, I said in an even-odd issue, and I didn't describe that first because it's sort of hard to describe, but now you can sort of see where is the even-odd issue right now. The problem is 13 because coefficients in front of formulas need to be whole numbers. So there is no whole number that we can put in front of O2 in order to make 13 O's. We would have to have 6.5, or we'd have to have 13 halves or something like that, 6.5. Okay? But we need whole numbers, okay, in order to do that. So you could do a fraction, but then you'd have to multiply everything through to get whole numbers. Okay? Often what I think is just easiest is in this kind of issue where there's no whole number you can use, try doubling all the other coefficients, and then you'll have an even number that you can get to. So, remember what coefficient was this when it was blank? That was a 1. So if we double that hidden 1 there, that's now 2. That 4 becomes 8. That 5 becomes 10. Then what we can do is update our little totals. Okay. 2 times 4 is 8. 2 times 10 is 20. Haven't changed the O yet over here. Okay. On this side, these numbers should double if we did it right. Right? 8 C's. 10 times 2 is 20 H's. And then how many O's do we now have over here? Yeah, we got 8 times 2 is 16, plus 10 is 26, which is an even number now. So what could I put in the box then in front of O2? I could put 13 there now, because 13 times 2 is 26. Turns out that this number is how many O's that we used to have over here before we doubled everything, right? Just a handy way that that works out, okay? But because we have O2 over here, because we have a diatomic element, no matter how many of that formula we have, it'll always make an even number of O atoms, because it'll be twice as many atoms. So if you've got an odd number of atoms over here that you're trying to match, it's not going to work. You have to maybe double everything else, except for the one that's sort of in question, and that should make this odd number even. And doubling any odd number will make it even. So we'll be using this trick several more times. We'll see this kind of, for a particular type of equation that we're balancing, this even-odd issue comes up about half of the time. Okay? That's because roughly half of all numbers are odd numbers. So that's typically why that works, but that's just one way of doing it. If your mind works with fractions, if you're a good fraction-y person, you could put a fraction in there, but then you'd have to multiply that fraction through to get all whole numbers anyway. So pretty much the same thing. So always make sure all coefficients are reduced to the simplest whole numbers also. So maybe you're doing some trial and error, just kind of going back and forth, and you find at one point, okay, I'm balanced now. A check that you should make is to make sure that they are all simplified, if possible. So if you had like a 2 and a 2 and a 2 and a 4, or something like that, that could very well be balanced. Okay? But the correct way to have it balanced would be if all the coefficients were reduced. So that would be reduced to a 1, a 1, a 1, and a 2. Okay. In other words. If you're really going step by step, one element at a time, this kind of method really usually makes it so that the answer you get is already reduced. But there are a lot of times, if it doesn't fit one of these molds exactly, that you'll just be kind of you'll just kind of be putting coefficients on things and updating your totals. And that's the typical way of balancing, right? You find one element, you put a coefficient, update its total. Oh, but then that screwed up another element. So you'll put a coefficient in front of that. That one fixes that one. Okay, look at the totals. Oh, but that screwed up another one. So you just kind of go back and forth, and eventually you should be able to get it. But some of that trial and error can sometimes lead to reducible coefficients. Okay. All right. This one, number 3 here, is not quite as common, but there are certain sort of troublesome equations that can be very easily balanced sometimes using this little trick. So maybe look for this little trick if you're having trouble with an equation. Okay? That if just going back and forth, you keep running into a wall and just making it worse. So you can sort of try this one. If an element appears in one compound on each side, balance that element first. What I mean is, if an element only makes an appearance in one compound on each side. So here, there's just one compound on that side. But over here, there's an element that only appears in one of those two compounds. Which one is it? Yeah, it's the oxygen. Okay? Oxygen is only here, and oxygen is only here. Okay? Once on the reactants and in one compound on the product side. So if that's the case, then these coefficients right here must balance oxygen. There's no other way to balance oxygen than with those two coefficients there. So use a least common multiple type thing to get the simplest balancing of that element, oxygen. Okay? So if we were to do that, what should I put here? What do you think? Yeah, I should put 4 here, because that gives us 12 O's on that side. And I should put what here? I should put 3 here, because that gives us 12 O's on that side. Okay? That's sort of the least common multiple for 4 and 3. I think that's how that works. Okay? So doing that will oftentimes simplify these to the fact that it's probably already balanced. Because look at P. Right? I've got 4 phosphorus over on this side. I've got How many phosphorus on this side? 3 times 1 is 3, but then plus 1 more over here. Okay. What about O's? 12. Oh, we did O's. What about H's? 12 H's. How many H's total over on this side over here? Yep, 3 times 3 is 9, plus 3 is 12. Right? So, you're going to write P4. So, all we had to do was that least common multiple of oxygen, and that balanced that one out just fine. But it's ones like that where you could kind of get yourself into a little trouble going back and forth if you're trying to get those H's balanced or something like that, and you're putting coefficients over in front of the pH3. You could get to a point where no matter what you do, it just sort of makes it worse. So when you find that happening and you're going back and forth like more than 2 or 3 times, and it just kind of keeps getting worse, just start over. See if you can find one element on both sides that there's just one way to balance. Okay? And oftentimes that will really, really simplify some of those more complicated ones. Okay? Another trick that will really simplify things, right, because that's a lot of atoms. S's and O's and 4's and N's and parentheses and all that stuff. Okay? And if you were just doing this by atoms, you know, how many O's are there on this side? 4. There are like 10 O's and 7 O's over on this side, and that would be really tough. But if you recognize polyatomic ions, like sulfate here and nitrate here, if all of the polyatomic ions are the same on both sides, like here's nitrate again, and here's sulfate again, if we use the same polyatomic ions, let's group them and count those groups instead of counting atoms. So instead of counting, 1 S and 10 O's or whatever, let's count 1 sulfate over here. And let's count 2 nitrates. So if you look at it that way, if we've got 2 nitrate groups over here, what do we have to do on this side to get 2 nitrate groups? We got to put a number 2 there. Okay. Could I have just done this? What's the difference between doing this and doing that? Yeah. And which one of these is completely and totally wrong? Can't do that at all, because this is the formula for sodium nitrate. Sodium is +1, nitrate is -1, and we can't change that. Okay? So resist the temptation to go modifying your formula in order to balance something. Get the formulas written correctly based off of the charges. We're going to have lots of practice with that later in this chapter. Okay? The only thing you can do is use a coefficient to balance it. Okay? So what else do we have to do to balance this one? Do we have to do anything else to balance this one? The correct answer to that last question was nothing, because this one is already balanced now. That's all you had to do. Because look, we made 2 nitrates here, but that also gave us 2 sodiums. Okay? So then we'd have to go back here and see what we have to do about those 2 sodiums. But look, there are already 2 sodiums right there, so we're all set. See? So definitely writing down those totals, okay, is the best thing you can do for balancing. Your goal should be to be able to balance an equation by sort of looking at it. Okay? So while you're still practicing it, write down those totals. By all means, update the totals each time after you update the coefficients. Okay? But your goal in an equation like this should be being able to see, I got 2 nitrate groups. Okay, so I better put a 2 here. That then gave me 2 sodiums, so I'm going to look over here. Hey, I already have 2 sodiums. Let's double check. I got 1 calcium, got 1 calcium, got 1 sulfate, got 1 sulfate. We're all set. Okay? That should kind of be what's going through your head of a proficient balancer. Okay? Now, I will also tell you one thing about balancing. Some of you will just take to this like no problem. Okay? For some of you, your brain works, you can solve number puzzles like this. This is just kind of like a little number puzzle. And for some of you, you'll just kind of be able to go back and forth, and boom, that's fantastic. Okay? Some of you will really struggle with this and will really, really have to practice it. Okay? And I promise that says nothing about your intelligence, because that's just how different people's brains work. Okay? But figure out what kind of person you are. If you need to do a little bit of practicing on this and you're good, that's great. If you're having trouble with this, you need to practice this a lot until you can do it really quickly and accurately. Okay? So I have a chemical equations worksheet in the usual place in D2L. Okay? That has a lot of things like this, where it's just blank coefficients, and you just need to enter the numbers to get it balanced. Okay? And I've got a mix of really pretty simple ones and probably some of the most difficult ones I could find. So if you can get through that, then you're doing great. Also, writing chemical equations from scratch. Okay? There's some of those on this practice worksheet. So let's do this for practice. This is another skill that we'll have to do, because oftentimes when a chemical reaction is described, it's described in a complete sentence using the names of those chemical substances, just like here, solid sodium and liquid water combined to create sodium hydroxide solution and hydrogen gas. That's a perfectly normal description of a chemical reaction. We should be able to translate that into a balanced chemical equation. So first order of business is to take those names and make formulas from them. Okay? So make a formula for, and as you're doing this, let me also show you this. As you're doing this, leave room for a coefficient. Okay? Have a chemical formula. I'll do sodium because that's just Na. Okay? And then a phase label. Anytime you're writing an equation from scratch, do it just like that. Leave room for a coefficient, write the formula of the substance, and a phase label. Okay? And if we got another thing, anytime you see and, that's a plus. Okay? Usually wherever the verb is in the sentence, or it's talking about forms or creates or makes or something like that, how do you represent that in the chemical equation? That's the arrow, because that's when you're starting to talk about products. Okay? So why don't you see if you can do that. First, though, make sure you get those formulas correct. Don't worry at all about balancing until you have all the formulas down and that those formulas are written correctly. Let's just take a few minutes, see if you can do that. Get all the formulas. The phase labels just come from the description. Let's see if you did it. Remember, coefficient, formula, phase label each time. If you don't quite know what hydroxide is yet, that just means you got some work to do over spring break. There is a list on the front cover of your notes, but see how you did. It's a solution. Solutions are aqueous. Yep. So formulas are right. The balancing is not quite right. because you got 14 H's on the right. Okay. Yes, yes, yes. Oh, but not just H. Yeah, there you go. Remember, hydrogen, when hydrogen is by itself, when we have hydrogen as a reactant or product, hydrogen is what kind of element? Hydrogen is diatomic, so don't forget about that. There are 7 diatomic elements. Whenever any of those is just a reactant or product, you have to use its formula correctly. Good. Sodium and H2O. Sodium hydroxide, not just hydroxide. There we go. What is the formula for sodium hydroxide? Yep. What is the formula for hydrogen? H2. Gas. Okay. Solid, liquid. Oops. What is the phase label for the sodium hydroxide here? When it is a solution. What is that another word for? It's another word for aqueous. In fact, aqueous is usually called an aqueous solution. Okay? That means it's been dissolved in water. Okay? Didn't need any numbers or any parentheses. I made it a little easy on you because sodium's charge is +1, hydroxide's charge is -1. So we just needed one of each, but definitely not always be that easy. Okay. 1, 2, 1, 1, 3, 1 to start out with. This one could be a little bit challenging to balance, especially if you get kind of off on the wrong track. This is also one of them that you could have some trouble with, although that least common multiple method is not going to help you too much in this one either, because you've just got one O in H2O and one O in Na, and our problem is with the H's. So, anybody have any recommendations for a first step we could take here? What do you think? Doubled H2O first. That seems like a reasonable thing. Any reason why you did that? Okay. Mm-hmm. Yeah. Sort of the thought process that, I don't know, you could think of this a lot of ways, but no matter what, we got 3 H's over on the left, right? And we're only starting with 2 H's on the right. So no matter what, we're going to have some coefficient in here. It's going to be impossible for this to be blank because there's not enough H's. So sometimes when it's like that, and when we've got H's in multiple places, when we've got that element in multiple places over here and kind of an odd number of them, if we increase the coefficient here to an even number, usually we can put a coefficient in one of those places to get them to equal out then. Okay? And I have yet to think of a simpler way to say that, to make a nice little trick out of that. But that's kind of the, if you don't have enough, give yourself a little more than enough trick. I mean, obviously, if this were an even number, we'd be able to just put something here and just make the right number. Okay? But since this is an odd number, instead what we have to do is give us more than enough. So then we can then go back to one of these to hopefully get it to balance out right. So if I've got 4 h's, what could be something we could do over here to give us 4 h's? If I put a 2 in front of NaOH, first now I got 2 sodiums, I've got 2 oxygens, and I've got how many h's now? Yep, I got 2 in here, and then plus those other 2, I've got 4. There. So now we're almost done. Now what's the last thing? Yeah, and we're good. In our next lab, we're going to have one that balances kind of like this, where we don't have enough of one element, but it's kind of an odd number, so we have to give ourselves a little, so we have to bump that up so that we have more than enough, because then we can go in on one of them and make it even and make it enough. So that's probably a better way to explain that, but that makes sense. Okay, so let me show you this worksheet here. Practice worksheets. By the way, you should be doing these naming worksheets, especially as you get to be pretty proficient at it. Do this mixed naming worksheet. Okay, that's going to be kind of what the quiz will sort of be like. I may ask you for ions as well. Okay, but then this one right here, chemical equations. Okay, practice balancing, but also practice writing equations from scratch from word descriptions. Okay.